In this problem, we are supposed to implement a spell checker. So you should download this file from this URL and then follow the instructions and then cd into speller. So I'm going to start coding this up. Meanwhile, smash that like button. So what's going to happen is I'm going to include ctype.h, include standardir.h, include string.h, and I'm going to include some more libraries like stdlib.h. Then I'm going to define the hash table size, my hash table size, as 1000. There are a lot of ways of solving this problem, and there are actually this kind of problem can be solved in many different ways with varying levels of performance. So I'm going to just do a simple version in this video, and I want to keep this video short, but you must try to improve this solution. Okay, I'm just going to do a simple one. I'm going to create a node here, and what's going to happen is this is going to represent a node. So what is this? This is the linked list node. So what's happening is we are in this linked list node, we are going to have a string called word and then a pointer to the next linked list. Okay, to the next linked list, like this. All right, so this is going to have a word, and maybe this points to another linked list, or it points to null, something like this. So I'm creating a node here. Then after that, I am going, this is, by the way, this is already present in the skeleton code that's provided, but I'm going to write it again. Now I'm going to include, this is a hash table. Okay, so what is going to be inside my hash table? In my hash table is essentially an array of node pointers. So there's going to node pointer 1, node pointer 2, node pointer 3, and so on. Okay, so this hash table is going to have the addresses of these nodes, and in all these nodes, inside these nodes, we're going to store our words. Okay, the words are going to be stored from the file that we are going to take in. All right, after this, I'm going to use an unsigned int, the number of words in the dictionary. Let's call this number of words. Okay, and then I'm going to say is loaded dictionary. Is the dictionary loaded? Is loaded dictionary, or is the dictionary loaded? Then I'm going to say I have a hash function over here. So the hash function, there are many different ways of writing this hash function, and this is just one of the ways of writing a hash function. I'm going to reiterate this again. There are a lot of ways of doing this. So what I'm going to do for my hash function is I'm just going to initialize hash to be 0, and I'm going to loop over my string over here, char word, and I'm going to start with I equals 0 while word of I is not \0. So I'm going to iterate over the word that I've got as a parameter, and then I'm going to check if the word, the ith word, the character, okay, the ith character is an alphabet. If it is an alphabet, I'm going to set n to be character minus a plus 1, and otherwise I'm going to set my n to be 27. Now why this sort of logic? This is just one way of doing this hash function, and there are many ways of doing it. Okay, so I'm just going to multiply this by this plus 1. The math of this is actually kind of beyond the scope of this problem set, just a way. And then finally, the only thing you need to know is that finally what we do is we are supposed to take modulus with this hash table size, so that once we take this modulus, we can return hash, and this will ensure that whatever index we calculate, this is going to remain inside the range 0 to hash table size minus 1. Okay, so once this is over, we can write our check function. So bool check. Check, what it does is, given a word, it's going to return if that word is present in my dictionary or not. So to do this, I'm going to iterate over my word. So what I'm going to do here is I'm going to say, first of all, what I need to do is, word can be given in a lot of different forms. So word could have a mixture of uppercase and lowercase. So what should I do is I should take this word and convert this into a lowercase, but I can't do that because this is a constant char star. So I'm going to take another temporary sort of character array, and then I'm going to copy using stir copy. I'm going to copy this word into my check word variable, and then what I'm going to do is I'm going to iterate over check word. So while check word is not \0, I'm going to iterate, keep on iterating, and then what I'm going to do is I am going to use the toLower function provided inside ctype.h to lowercase convert this check word which I have copied from word into lowercase letter. Okay, after having done that, converted this into a lowercase letter, then what I'm going to do is to check whether this word is present in my hash table or not. I'm going to find out the index using this hash function. Okay, I'm going to use check underscore word, and then what I'm going to do is if the hash table, so we are returning a hash from the hash function, if the hash table, if I look at the index, okay, and in the beginning all this array is going to be null. So if any of them is null, then I know that there is no further linked list attached to this, so I know that I can return false straight away in that case. Otherwise, if this is not null, then there must be a couple of nodes inside them, right? So there must be a couple of nodes like this. I need to traverse the entire linked list, so to speak. I'm going to start writing the code for traversing a linked list. I'm going to have a node pointer. I'm going to start with this hash table index, and then I'm going to check if node pointer exists, which means node pointer not equals null. I'm going to say node pointer equals node pointer next. Alright, after this I'm going to say if I'm going to compare at the current node pointer's word, at the current nodes I'm going to look into the word of that node, and then I'm going to check stir comp it with check word, and I'm going to see if they are equal, and I'm going to return true. Otherwise, I can return false. I'm returning false if I didn't find that index, or if I have searched through the entire linked list associated with that index in the hash table. Next up, I'm going to use this load function to figure out or to load all the words from a file into the dictionary, into my hash table essentially. I'm going to say file star file equal, or in file, let's call this in file, is equal to, I'm going to open this dictionary. The name of the dictionary is provided over here, my parameter, and then I'm going to read that in. So I'm going to say r, and I'm going to say if in file is null, I'm going to simply return false because I couldn't load my dictionary into my hash table. Now after that, I'm going to initialize, I'm going to initialize my hash table with null values. So I'm going to say hash table of I equals null, and after that I'm going to use this in file. I'm going to use the fscanf function from this in file. I'm going to read in a string into a character array called word, and this is going to be size length +1. As you can see, not over here, but in string in dictionary.h, length of the maximum length is defined. It's like 45 or something. Okay, after having done this, what I'm going to do is I'm going to read this. Okay, I'm reading this, and I'm going to check whether this is end of file or not. If this is not end of file, then I can continue. I can say number of words in this dictionary, which is over here. Number of words, I can increment that, and then I can say, you know what, I'm going to create a new node pointer. New node pointer equals malloc size of node okay, and if we have to check for null every time we use this is null. Let me free this new node pointer. This is just sanity check. So while new node pointer equals null, I'm going to try create this. You could also not use this loop, and simply what I'm doing is I'm creating a new node pointer. Okay, and this is just extra work which is not required. Then after that, I'm going to say this. I'm going to copy from new node pointer word. I'm going to copy this word that I've received from the init file into this new node pointers word field. Okay, having done that, I'm going to look at the index, okay, from the hash table. I'm going to look at from the hash function. I'm going to get the index. I'm going to say if hash tables index, if this is not if this is equal to null, then I need to create a new node, so to speak. I'm going to say new node pointers next equals null, and hash table index equals new node pointer. Okay. Otherwise, if we just add a new node at the head of the linked list, what should happen here is new node, we are now adding a new node pointer next equals hash table of index, and then hash table index is equal to pointer. So what we can do here, instead of doing this in two cases, what we can simply do is we can do this. We just use this, right? Hash table of index equals new node pointer. You can see if this is null, you can just remove this part. Reason being, if the hash table of index is null, then this is null, and then this is also equal to new node pointer. So we generalize this. After this, we can just close this file, fclose in file, and we can use a function called this variable, boolean variable is loaded dictionary. Initialize that to false. It should be initialized to true because we have actually, and then we're going to return true because we have. So this should be initialized with false over here. Initialized with 0. Okay. So after having done these two functions, next up we need to write size function, which is pretty simple. Unsigned int size void. This is going to simply return the number of words in the dictionary, which is a global variable, and if the dictionary has not been loaded, then I'm going to say return 0 in that case. Now to unload this dictionary, that's the last thing that we need to do here. Let's say bool unload void. What we need to do here is we need to unload all and free all the linked lists. So if the dictionary has not been loaded, then we can simply return false. Otherwise, we need to iterate over this hash table, I less than hash table size, I plus plus. If it so happens that hash table of I, if that's not null, then we should free this thing. Okay. What we can do is we can start off with a pointer this address at hash table of I, and we can say while this pointer is not null, we can iterate over all the nodes in this linked list. I can say I have a predecessor pointer to this pointer, and then I can say pointer equals pointer next, and I can free this predecessor pointer. Okay, and then finally we can return true after we have successfully done all the work. Let's make this up, figure out where we've made some errors. Check word is too lower, it's not assignable. Check word of I, this should be check word of I over here. And then let's see once more what to do. Let's make some errors over here. 976. Pointer is malloc size of undeclared identifier, so we must declare this identifier node star new node ptr. All right, let's make it again. Index equals hash word. You know what, say int index, make it again, and then we have equals hash table of index. Typo over here. All right, so now we should try some examples, run this program, and I'm just going to keep this video short. I'll check 50 on this. Meanwhile, we're just trying to look at what's going on here. So what we did was we initialized this hash table, and then we used number of words and we initialized that to 0, and then we initialized this variable to false, and then we use a hash function over here. As you can see, we've got everything correct. I'm going to summarize this one more time. What we did here was we used a hash function to return the index of which, given a word, we returned an index. So this hash function can be whatever, but this is just one of the hash functions. You don't need to understand the math behind this. The only thing you need to understand is this returns an index from 0 to n-1, or hash table size -1, and a hash function should be deterministic, and there are a lot of hash functions. Okay, this check function, what it does is we check if current word is in this hash table of ours. To do that, what we do is we convert it into a lowercase letter, into all lowercase letters. Then we look at the hash table at the index using this hash function, and then if it's not null, we traverse the linked list and check if the word is present over there. Otherwise, if the word is present over there, we return true. Otherwise, we return false. In this load function, what we do is we open this dictionary file, and then we initialize our hash table to all nulls, and then we are using this fscanf while we're reading in words from a file. We're incrementing number of words, which is a global variable, and then we are basically creating a new node. Okay, and this is some error checking going on over here. After that, we are copying this word into our new node pointers word field. We're calculating the index. Then we are, assigning that word over here and attaching that to our hash table. Okay. So what is happening over here is we are adding this word to the head of our linked list. Every time we're inserting, we're adding that word to the head of a linked list. So this is order of 1 operation. We're closing the init file, and then we are flipping this variable, boolean variable, to true. In size, if this dictionary has not been loaded yet, we're going to return 0. Otherwise, we're going to return the number of words. Unload, if this dictionary has not been loaded yet, we are going to return false. Otherwise, we're going to iterate through the hash table, and we're going to free the linked lists. Okay. To do that, what we're going to do is we are going to maintain predecessor pointer, and we're going to free the predecessor pointer and move the pointer forward. Okay, the order is important here. So that's pretty much it. Like, subscribe. Peace.